Now that you have two FBX files to test out, you start by experimenting with the day scene. In 3ds Max, reset your scene. Import and link the day scene you created earlier, or you can use the provided file named room day FBX to that effect. Use the combine by family type method as you have done before, and attach the file. Because Revit always exports the daylight system, you are prompted to use exposure control. This is needed to compensate for the brightness of the sun, much like with a real-world camera. The default exposure value is set to 15. It is a good starting point for daytime rendering. Click Yes to proceed. The scene gets loaded. Zoom out and take a look at your scene. Note the presence of the exterior camera and that of the daylight system. Click an empty point in the viewport to deselect all objects. If you look closely, you'll notice that the artificial lights inside the room are shown in black. This is an indication that they are disabled. To make it easier to see inside, you can hide the curtain wall. This can be done by selecting its components in the viewport and then right-clicking and choosing Hide Selected. Another easy way is through the Scene Explorer. Sure enough, if you were to select any interior light and check its parameters in the Modify panel, you can see that it is inactive. That's fine for the day scene. The daylight system, on the other hand, is certainly active and is made of a direct light source, or sunlight, simulating the sun, and a global source, or skylight, simulating Earth's atmosphere. Go to the Motion panel and notice the time of day is set to 1400, or 2 p.m., as specified in Revit. If you were to make changes to the time of day, or the north direction, there is not much feedback in the viewport. This is because the viewport is set to shaded mode by default in 3ds Max Design. You can click that label and switch the mode to realistic. Still, not much change when you edit the daylight's parameters. You may need to disable adaptive degradation depending on system performance. Click the realistic label again and choose Lighting and Shadows, Illuminate with Scene Lights. The viewport shading is now affected by the lights in the scene. Now try to change the north direction and see the feedback in the viewport. Settle for a 265-degree angle. Press C to set the viewport to display the camera viewpoint. And do a test render. Not bad, but we can still tweak it a little bit. You can see the effect of direct sunlight and shadows. You can also see the effect of global lighting as it illuminates the surroundings and the inside of the room. This requires tweaking as well. Notice also the background, as it shows a sky with few clouds, as specified in Revit. Let's see how we can make things better. First, let's do the same test render in higher resolution. This will make it easier to see detail. Click the Render Setup icon on the render window. It can also be accessed from the main toolbar. Set the output size to HDTV. This will result in a nice 16:9 aspect ratio. Choose a preset dimension or type in a value. For this movie, I'll use 960 by 540. Dismiss the dialog and test render again. In general, the rendering is still a bit dark. You'll need to adjust the exposure value in a second. Click the environment icon to access that dialog. Set the EV value to 14 and try again. This is better. Overall, the scene is brighter, and we can make out the inside of the room. The clouds in the background are a little less visible, though. The clouds, and the background for that matter, are part of a special map called MR Physical Sky. This usually gets defined when you create a daylight system, including when you import it from Revit. So in essence, a daylight system is really made of three components: a sun, a skylight, and a background in the form of the MR Physical Sky map. The reason I mention this is because the three work together. Typically, all three should be enabled or disabled together for the scene to work well. More on that when we test the night render scenario. For now, to make the clouds more visible, open the Material Editor. Drag the MR Physical Sky map from the Environment dialog into the Material Editor as an instance. Double-click the Clouds Map node and set the brightness slider to about 20. Test render the scene again. The clouds are now more visible. Do not go overboard with this slider though. Too high a value usually yields unexpected and unwanted results. As mentioned a second ago, the inside is still a little dark. If the building was meant to be viewed from the outside only, you'd be fine with this setup. But if the building is meant to be open or transparent, so we can peek inside, then you need to do some extra work. There are many ways to improve the rendering solution. First, you can improve the quality of the rendering by increasing the final gather precision and the number of FG bounces. Final gather precision increases the number of rays needed to calculate the solution, while FG bounces defines the number of times these rays bounce off surfaces to add to the global illumination solution. Keep in mind that while this can give you some promising results, it can also increase rendering time exponentially. The same scene that took 15 seconds to render a moment ago is now taking about 1 minute 20 seconds, and this is a very simple scene. Personally, I always try to look for ways to keep rendering time at a minimum, even if I have to rely on non-physically accurate methods. One of my favorite methods is to use a light source for ambient lighting only. Create an omni-light, which is the same as a point light, anywhere in the scene. Use the Move tool and the Transform type-ins to relocate it to 0, 0, 0. This is essential for this method to work. In the Modify panel, go to Advanced Effects and ensure the light works in ambient-only mode. That's all you need it for. Because an omni-light is not physically accurate, you'll need to fiddle with its parameters. This is especially true when you use it in combination with the daylight system and exposure control. Currently, it doesn't have much effect on the scene, if any. In the Modify panel, set the light's multiplier value to about 3000. You can experiment with this if you want. Test render again. The inside is brighter, but now appears a bit washed out. To bring more shadows where surfaces intersect, you'll use ambient occlusion. This is a process invented by ILM and often referred to as a dirt map. In effect, it darkens areas where surfaces intersect, in this case mostly the walls and floors. With the light still selected, click the Projector Map button and set it to use an ambient reflective occlusion shader from the Mental Ray Maps list. A test render at this time takes you back to the original look, but that's only because you need to adjust the ambient occlusion shader. Drag the ambient occlusion map to the material editor as an instance. Double-click it to view its parameters. At this point, you're really only interested in the maximum distance value. You want to set a value here to tell 3ds Max how far to look for intersecting surfaces. A value of 0 looks to infinity and is not recommended. Set it to about 3 or 4 feet. And test render again. This is much better, and still rendering in the 15-second range, so this method doesn't penalize rendering time much. You can also see how much nicer a rendering with ambient occlusion is if compared to one without. Now that you've taken a look at the daytime scene and how to set it up, you will next look at defining a night scene. This is what you do in the next movie.